Hi, my name is Victoria Purcell. I'm a PhD student at the University of Leeds. Going to be talking to you today about the long-term volcanic deformation observed in Lanzarote using InSAR data. Lanzarote is one of the Canary Islands just off the west coast of Africa. There have been two eruptions in recent history. In particular, the eruption in the 1700s was significant in terms of its size and duration. It lasted for over 6 years and the lava flows covered a significant portion of the island. These are still preserved today and they're easily identifiable in the coherence maps from the Sentinel data. Previous InSAR and GNSS results have measured a subsidence signal of 6 millimeters per year close to Timanfaya, which was one of the major eruptive centers of that eruption. And also there are some present day thermal anomalies there as well. Our aim in this study is to combine ERS, MVSAT and Sentinel-1 data to show that the subsidence signal remains approximately constant over the 30-year time span, and then eventually model potential sources for this signal. Initially, with the Sentinel-1 data, we inverted for the velocity using the standard method of 3 interferograms from each epoch for the network. This resulted in a very noisy velocity field with 2 particular areas showing large velocities, Yuga and Guazia, which we thought might be bias because they were not seen in the MVSAT and ERS results. So we decided to explore this more by varying the network used for the inversion. We tested up to 11 interferograms from each epoch. As you can see from the new velocity maps, the noise has been significantly reduced. And also the velocity distribution across the island is now more Gaussian, suggesting that the bias has been removed. And you can see those 2 areas, Yuga and Guazia, have become more stable. But the Timanfaya signal remains. Here we tested a different network again, this time made with 3 interferograms from each epoch, but increasing the average length of the interferograms from 13 days to 38 days. This didn't provide quite as good results as the 11 connection network, but it did have the advantage of using a lot less computational power and time to perform the inversion. Finally, as Lanzarote has really good coherence, we were able to make a stack of 1-year interferograms to compare with the velocity inversions. We then looked at the satellite data to see if we could find any potential causes of the bias. At Yuga, there are these man-made hollows, which are designed to capture moisture used by farmers. And then at Guazia, you have more traditional crop fields. Therefore, we think the bias is likely related to the land use type and soil moisture content as seen in other areas of literature. So putting all of that together with the ERS and MVSAT results, the geophysical signal is clearly seen in all 3 data sets and has a maximum magnitude of between 6 and 7 millimeters per year and is correlated spatially with the thermal anomaly observed at Timanfaya. This shows that the signal is long-lived and likely associated with one of the main eruptive centers of the 18th century eruption. Next, we will look to model the signal and suggest a possible cause of the deformation. Thank you for listening.